So the first problem that we are going to solve is from page 28, number 8. Given this equation, y dx minus x dy is equal to x times the quantity of dy minus x dx. So we are asked to solve for this differential equation, either separable, exact, homogeneous, or linear or Bernoulli's, in the most convenient way we can. So the first step that we are going to do is simplify this equation. So simplifying, we have y dx minus x dy is equal to x dy minus x squared dx. Simplifying it further by combining like terms, we have negative 2x dy is equal to negative y dx minus x squared dx. Multiplying both sides by negative 1, we have 2x dy is equal to y plus x squared dx. So we want to express this notation into standard form. So we have this dy over dx minus 1 over 2x times y is equal to x over 2. So this is already in standard form. Just by looking at it, we can now conclude that this is a linear differential equation. So in solving for a linear differential equation, after finding for its standard form, we now solve for the integrating factor. So an integrating factor is just equal to v is equal to e to the power of integral of px dx. So px of this equation is just equal to negative 1 over 2x. So solving, we have this. So we have the constant out of the integral, and we have that e to the negative 1/2 ln of x. Simplifying it further, we have x to the negative 1/2. So having the integrating factor 1 over square root of x, or x to the negative 1/2, we now multiply it to the standard form. So we all know that dy over dx minus 1 over 2x times y times the integrating factor is just equal to dy over dx times the independent variable y times the integrating factor 1 over square root of x. So we already multiplied x over 2 times 1 over square root of x, giving us square root of x over 2. So integrating both sides, we have y times this 1 over square root of x is equal to 1/2 x to the 3/2 over 3/2 plus c as constant. So after having this, we simplify it further by multiplying both sides by square root of x. So after multiplying, we have the answer y is equal to x squared over 3 plus c square root of x. So the next problem that we are going to solve is from page 32, number 2. Given this equation, sine x over x squared plus y squared, we are going to test for its homogeneity. So the first thing that we should do is let x be equal to xt and y be equal to yt. So substituting it to our first equation, we have sine xt over xt squared plus yt squared. So we squared all that was inside the parenthesis. We have sine xt all over x squared t squared plus y squared t squared. So we simplify it. We have sine xt all over t squared times the quantity of x squared plus y squared. So we can see that t can be factorable. So we have this equation, sine x over t times the quantity of x squared plus y squared. And we all know that this is not homogeneous. Why is this not homogeneous? It is because from this theorem, or from this statement, we have f of xt yt is equal to tn f of xy. So this equation is not on the same degree as t in the upper and t in the lower. Therefore, we can conclude that this is not homogeneous. The third problem that we are going to solve is from page 35, number 22. X squared y prime plus xy is just equal to 2 plus x squared. Given the conditions, y of 1 is equal to 0. So this problem is an initial value problem. And to solve for this equation, we have to change this equation into standard form. So don't be confused with y prime and dy over dx because they are just the same. I just wrote it in dy over dx to not confuse myself, and it is an easier way to not be ambiguous. So we multiply both sides by 1 over x squared. We have dy over dx plus 1 over xy is equal to 2 over x squared plus 1. So our px for this standard form is 1 over x. So solving for the integrating factor, we have v is equal to e to the power of integral of 1 over x dx, which is e to the ln of x, and simplifying it further, we have the integrating factor equal to x. So multiplying this to the standard form, we have dy over dx plus 1 over xy is equal to 2 over x squared plus 1. And since this is just equal to dy over dx times the quantity of the independent variable, which is y, and the integrating factor, which is x. So we already multiplied the 2 over x squared plus 1 times x. So we have this as the answer, 2 over x plus x. So we integrate both sides. We arrive to this, y times x is equal to 2 ln of x plus x squared over 2 plus c. So dividing both sides by x, so we arrive to this, y is equal to 2 ln of x plus x squared over 2 plus c all over x. So there are two types of answer here. Either this one, which is just equal to y is equal to 4 ln of x plus x squared plus c over all over 2x, if you want only one variable as our denominator. Or it can be y is equal to 2 ln of x all over x plus x over 2 plus c over x. They are just the same. To continue, we have the conditions y of 1 is equal to 0. So I use this answer, y is equal to 2 ln of x over x plus x over 2 plus c over x. So I substitute the value 1 and 0 to our answers. So we have 0 is equal to 2 ln of 1 over 1 plus 1/2 plus c over 1. So 2 of ln of 1 is just equal to 0. So what remains is 0 is equal to 1/2 plus c. So c is just equal to negative 1/2. So substituting it to our answer above, we have this. Y is equal to 2 ln of x over x plus x over 2 plus negative 1/2 times 1 over x. So we have y is equal to 2 ln of x over x plus x over 2 minus 1 over 2x. So this is the answer for the initial value problem of our third problem. So our fourth problem is from page 38, number 14. It is still an IVP problem or an initial value problem. Given the equation y prime plus y is equal to y squared. And the conditions y of 0 is just equal to 1/2. So I change y prime into dy over dx and transpose y to not confuse myself. So this equation can be or is a separable differential equation. So we have to put all the same terms in the same side. So dy over y squared minus y is equal to dx. Since we know that we can't solve it immediately, we have to use integration by parts to arrive to this point. So integration by parts is in this process 1 over y squared minus y is equal to a over y minus 1 plus b over y. So ay plus by minus b is equal to 1. A plus b is equal to 0, and since negative b is equal to 1, so b is equal to negative 1, which concludes that b, or I should say a, is equal to 1. So changing the variables of a and b, we have this. So we simply integrate this both. So dy over y minus 1 is just equal to ln of y minus 1, and dy over y is just equal to ln of y. Same as true with integral of dx is equal to x plus c. So simplifying this further, we have ln of y minus 1 over y is equal to x plus c. So I multiply both sides by e. So we have this. And simplifying this further, we have y minus 1 all over y is equal to e to the x times e to the c. They are just equal to e to the x plus c. Or we can have it this way, y minus 1 all over y is equal to e to the x times e to the ln of c. They are just the same because c is constant, so we can manipulate c whatever we want it to be. And what is easier to solve for c? So we have this as an answer, but I prefer this as our final answer. So y minus 1 over y is equal to c times e to the x. Continuation. Since we are given the conditions y of 0 is equal to 1/2. Given our answer y minus 1 over y is equal to c times e to the x, we are going to substitute the values of 0 and 1/2. So we have it here, and we all know that e to the 0 is just equal to 1. So what remains is c is equal to negative 1/2 over 1/2, which is just equal to negative 1. So substituting negative 1 to our formula, or the answer a while ago, we have y minus 1 over y is equal to negative e to the x. So checking if our answers are correct, we have differentiate the left side by y with respect to y, and this with respect to x. So low d high minus high d low over low squared, we have this as an answer, and this as the we differentiate the e to the x, negative e to the x. So simplifying it, we can cancel the y prime minus y prime. So all we have left is the y prime over y squared and the negative e to the x. We all know from our given answer is that negative e to the x is just equal to y minus 1 over y. So we substitute the value of y minus 1 over y to this function. So we have this dy over y squared is equal to y minus 1 over y times dx. So dy over dx is just equal to y squared times y minus 1 over y. So we all know, as I have said earlier, is y prime is just equal to dy over dx. So we have this as an answer. Y prime is just equal to y squared minus y. And from our given, from the original given equation, we arrived at the same exact answer. So which means that our solution is correct. So for our application, we have this problem that a tank has a shape of an inverted right circular cone of radius r and of height h. If there is a hole at the bottom of the tank with a radius r and drains under the influence of the gravity at any time t, what is the time when the tank will drain completely? So from the given formula of a circular cone, we have V is equal to 1/3 pi r squared h. So this is the volume from this. And V is equal to square root of 2gh. So this is the velocity of the draining. Now we have to differentiate the volume in dV is equal to negative 1/3 pi x squared dy. So you are wondering why it is x squared. So I have replaced x with r. It's because at time t, x is decreasing. The radius is decreasing, that's why we represent it with x. And you might be wondering why it is a negative. It is negative because it is decreasing. So as at time t, we know that the water is decreasing inside the tank. So we have it negative. So this is the water inside the tank. So we all know that area times length is the volume. So solving for what comes out, the volume that comes out from the tank, we have this: pi r squared square root of 2gh dt. So the r squared here is the hole at the bottom of the right circular cone. So RH here is replaced with Y. Why? Because H is decreasing at time t, so it is not constant, so we have it replaced with Y. So this is the volume of the water that drained, or the volume of water that goes out of this tank. So we all know that the volume of what's inside is just equal to what will go out when the tank will drain completely. So what goes in is just equal to what goes out when the tank will completely drain. So this equation is just equal to this equation. So we have it here. 1/3 pi x squared dy is just equal to pi r squared square root of 2gy dt. So since our x squared is not defined, we are going to use ratio and proportion. So x over r is just equal to y over h. So we are just looking for x, so we multiply both sides by r. We have x is just equal to r y over h. So we substitute this value here. That's why we have it here. Negative 1/3 pi r squared y squared over h squared dy is equal to pi r squared square root of 2gy dt. So we combine like terms here to have a simpler integration for the next process. So that is why we have y to the 3/4 It's because we have this square root of y transposed to the other side, and the constants to the right side. So integrating both sides, the result will be y to the 5/2 all over 5/2 is equal to negative 3 r squared over big R squared h squared square root of 2g t plus c. So simplifying our answer, we have y to the 5/2 is equal to negative 15 r squared h squared all over 2 r squared times 2 square root of 2g t plus c. So that is our answer for the first part. Now since we are looking for the constant c, so we let t be equal to 0. So if we let t be equal to 0, what remains is y to the 5/2. And since y is just from h and we are looking for c, so we are looking for the constant. That's why we have it c is equal to h to the 5/2. Now we substitute c to the formula we have here, to the equation we have here. We have y 5/2 minus h 5/2 is equal to negative 15 r squared h squared all over 2 r squared times square root of 2g t. And since we are looking for, our main concern is the time when the tank will fully drain, so we let this, we are looking for time, so time is just equal to y to the 5 over 2 minus h 5 over 2 all over negative 15r squared h squared over 2r squared times 2g. So simplifying this further, we have t is equal to negative 2 over 15 times the quantity of r squared times y to the 5 over 2 minus h to the 5 over 2 all over r squared h squared times 2g, square root of 2g. So our final answer would be t is equal to 2 over 15 times r squared times the quantity of h to the 5 over 2 minus y to the 5 over 2 all over r squared h squared times square root of 2g. So this will be the time that the tank will fully drain with respect to the influence of the gravity.